connector, you will not see here a huge amount of data that are sending in a single packet. Client or server or whatever your service will try to send it in more small portion of data and in a smaller packet. And from client or server side, it will be more, in most cases, it will be more effective than trying to collect all this data on server side, serialize it, and send it bigger batch size. And what pros and cons we have here? So when we are talking about classic HTTP application JSON, sometimes it's faster, and applications meanwhile JSON doesn't have real big pressure that we'll talk a little later. But it's faster because it releases the resource faster. Doesn't need to collect more data on the server side. Okay, it's really faster why we don't use it everywhere. Yeah? From previous slides, it looks amazing. Because when we have like benchmarks that are trying to send different packages or messages with different size in different messages in a single packet, you could see here it's a graph with logarithmic scale, so it's really different, but to read it, it's more easy. So here you could see it's JSON, simple JSON serialization, and here is delimited JSON. And in some cases, JSON serialization is really faster, and it's really faster when we use small data, like really small messages, and that doesn't fit really good for streaming. And it loses when we have we need to send more data, more messages, and package really fit good enough for streaming. And there mostly graphs for need delimited JSON, so streaming big messages after some sizes is more efficient and really fast. But if you have small messages, not streaming, it's really doesn't work to use it. So what is Reactive? Reactive, it's a model when you have a subscriber, you have a publisher, and you have some kind of subscription. And in this model, it's really different because in this model, consumer or subscriber decide who will send and when producer will send you more data. Because, for example, in classical way, when we have like client, it will send us HTTP request. It doesn't matter whether we are too busy or we have more resources, less resources. It doesn't ask us whether we are able to produce this request right here, right now. With Reactive, it's very interesting and good things. It's big pressure. So with big pressure, subscriber could control when publisher will send you more data, what it will mean. If we have millions of clients that are trying to send on our microservice a huge amount of requests, it will not happen. Our service degradation will not happen because we could ask, okay, right now, this connection, all this connection, please send us more data, and they will send us HTTP request. And from scale size, from availability, it's more better, it's more efficient. And like as a good best example for Reactive implementation, it's Spring Reactive server that built on over native that have like subscription of receiver and all this implementation, but it's have some disadvantages. For example, here is like a quick example of how HTTP the pressure is working. So we have here implementation of subscription with big pressure, and we tried here to implement the pressure based on HTTP web server. Doesn't have like real big pressure. So our service could ask web server, okay, I have some free resources, okay, give me more HTTP request. And here on the request, we'll able to see some code that will try to drain all this new data, process new events from the poll selector, like reading new events or trying to send some events to socket. But why I'm talking about that it's really not big pressure? Because it's have problems. When we're talking about Reactive built on HTTP that doesn't have real implementation of it, it means that, for example, if we stop processing data from our web server, fully process new events from sockets, we'll have problems with system quiz on system level with all these events, because on system level quiz will be overflow, and it will lead to more low-level problems that clients will not be able to connect to this service, and our operation system will drop new connections, and will be resource exhaustion. Because when we, for example, try to write web client or web server, you don't mind about how many threads you create, how buffers should be big enough. But at a low level, you need to understand that if you are not able to process all this incoming traffic in time, will be buffer overflow on the layers. And it's a problem with this implementation of HTTP reactive service on Spring with pressure. Okay, another things like we could have reactive applications on Spring, on with HTTP services, but what about like we have classical common application databases that are fully synchronous, like JDBC server, database drivers, that with which we are working, and for that we have reactive drivers that provide us reactive interface for working with databases. And it's like a simple example how to use reactive interface for this driver. So just you need to, in classic way, to create a connection to the database, and you can create and execute queries in a reactive way without any problems. So there is no really problem to switch from classical application with synchronous JDBC to something reactive. And also quick benchmarks or comparing classical application with JDBC drivers, with reactive drivers, and different web server implementation like servlet and reactive application native. And you could see that here reactive service with reactive drivers is very fast, but even with classical servlet, reactive is very fast. Because when we are using classical pooling to work with databases, they are not very effective. They also not good for resources, because you need to create a huge amount of connections, or maybe you don't create this connection, and all this invocation to the database will be synchronously, and it means that also you will affect your system database, and it will lead to problem with context switching and so on. Okay, so let's switch to socket and talk about really good reactive applications. So socket is a framework or library that provide tools to implement reactive client and real reactive applications. It's have support for multiple languages. So if you're writing on Kotlin, Python, it's or even JSON, it's very good. It's message driven, so it's all about streaming, and it's could be used. It's based on TCP, but it's also provide interfaces on WebSocket or WebSocket and HTTP. But it's all about raw TCP. And like if you want to write, create some applications, it's very easy. You just use 3 lines could create a new server. And if you write a client, it's also very simple. You could implement a simple client and provide its handler. And here, you could, based on your message type, also split, understand what is your message type, how to route it, how to work it with it, and it's very easy. It's like a short description. And this is about how to communicate. And when we're trying to communicate with RSocket, they don't provide us the same functionality as HTTP. We have headers, we have body, and other helpful stuff like with methods and so on. So here we have in base we have payload. In payload we contains metadata. It's something like headers in our HTTP request, and we have bodies that contains some necessary information for us. And for example, like what difference between classical applications and reactive application, as we talk about later before. For example, we have here send request that we need again to select some information from database or from logs. And from that perspective, what will looks like? We send a request with our reactive application. Our service could select something in a reactive way and fetch it. Okay, we are ready to send it back to the client, but we can't because nobody asked us about it, and it's a big pressure. And after a client said us, okay, I'm ready to receive your data, please send me next, for example, 5, 10, or whatever data. Server will send us some data. We could process, receive it, and after some time we could, okay, I'm ready for next data, please send me more data. And with it, we could organize more efficient services that could be send us with understanding whether our service on another side are busy or not. And it's like a quick comparison of how to switch from HTTP to RSocket. So we have headers in RSocket. We have metadata. So all data that you saw before in headers, you could write into metadata. Body you could store in data, and also all this combination of headers could be stored in metadata. Okay, so we have like a socket application, but we also have everyone use application. How to organize it in RSocket. Also with Spring we got it, so with just Spring configuration we could add reactive application now. That will say, okay, we'll store this GT in our metadata. You need to pass like this and authenticate with this, so no problems. And everyone, I think, that working with Spring or these frameworks, and really there is no difference on how big difference how to organize controllers. So on the right side you see reactive controller or REST controller that we have like method, we have flags, it's reactive stream of some messages that we return back, and we have something input. On left side we have reactive controller. It's used mostly the same notations and same body, so nothing magical or very hard. Okay, but client configuration sometimes could be very tricky. So when we want to send another request to another service, like microservice architecture, it could be quite different to configure it, but with Spring everything is could be done fine. You just need to implement how your request looks like, how it will serialize the data, because when we're talking with HTTP, it's have a content type that one could understand how to serialize, deserialize it, and we have a huge amount of utilities for that. In reactive way, it's not so much tools for that from default. So we need to explicitly set how we serialize data, how it's stored, how it will be encoded, how it will be decoded, and also it's a good thing that here on these lines we have some kind of reconnection logic and reply logic. When we're talking about HTTP, it's always talking about stateless services, but when we're talking about reactive applications, they're all mostly and always stateful. So when you lost some connections to the server, you need to understand that you need to reconnect to the servers, because you cannot just reply and read all context and to the server. Also, if you have like multiple servers, you need to store them in your own pool. So you need to handle this load balancing and reconnection logic by yourself, but with Spring and tools from this socket library, it's very easy. So you just configure how you reconnect, what you need to do, and how your pool will be organized, and that's all. And yeah, it's how our client looks like. So when we send our request with HTTP client, we send URI. Here we set route, and depends on this route. In most cases, Spring will put it into the metadata and understand that here's the route and how to route to real controller, and it will also work. And here we also have stream support. This means that we'll receive data in a stream way with also the pressure, and it could be also controlled. Okay, and also as we talk about our services, that they're always stateful. If you are using your service or deploy your service in Kubernetes, for example, it's not always clear that when we are trying or you're creating a certain service, Kubernetes will give you a public API for your service, and you will be if you will working with just a single API. It will be a load balancer that in HTTP applications will by itself route all this request to another host or your services that are running. With reactive applications, it's not so easy because they're stateful, and you need to close all your public IPs that applications have. This means that you need to create your make your service headless and provide all of your make it discoverable all IPs that you have. So by this, all clients could discover all these IPs and work it with it in their own pool. And like several also benchmarks, when we are comparing some applications like Socket, Reactive, and classical servlet, you could see that we have here some bunch of disadvantages. And for example, with the Socket, it's top line. You can see that it's like a straight line by itself, because in Socket from the its architecture, it's could consume or process its with normal throughput, because your clients respect how much data you could just now process, and you always have like a maximum limit of this data metrics, and this is why we have like a straight line. With Reactive or Webflux implementation of in Spring, there is no always such things, because clients, when you send some data to it, in some cases it's really fast in the beginning, but when a huge amount of clients are trying to send concurrent huge amount of requests without respect of how service is busy, it will be the worst case, because you're able to process this data, you're able to accept these new connections. But at the end, you will have a huge amount of connections, and you will not have enough resources, hardware resources, to process all these connections, and it will be linked to problems with less throughput than classical even server-led applications. And server-led applications anyway is slow because it doesn't provide async, full async model, and okay, and what pros and cons circuit yes have. It's really hard to debug. It's stateful. You need to implement your own TCP load balancer on your client, but it provides reactive streams, and if you're working with Spring, it's very easy to use. It's very effective. It's have really low transport overhead. It has multi-language support, and it's also provides a very good test framework that you could use from the box, like step verifier, and it's become very easy to use it in async life. And when you should use reactive or not avoid it. It's very good when you have high concurrency applications. With huge amount of clients, when you have work with a lot of input output, like databases, logs, you have streaming applications, unreliable network like you have ELT, or you have some clients that very distributed, and you need some kind of good pressure when it's not good. For example, but you need very low latency applications like trading or something like that, and because it's at some overhead, and it's sometimes very hard to predict why you cannot send a request and give it back, because from some time to time service is all busy, and he will not ask you, okay, give me another portion of data, and you maybe wait more data while trying to send this request. And when you have like very simple services that don't need one server single request. There's very good references if you want to research about reactive circuits. And I think that's all. If you have questions, please.
So questions?
Yep.
Don't virtual threads give you a lot of these benefits with a much simpler programming
So could you clarify the question?
So reactive has, like, you've got one of the cons is debugging is difficult.
Yeah.
And it means maintenance is difficult. Virtual threads gives you a lot of the same benefits, but with a much simpler programming model, so it's much more maintainable.
No. It's really not about like how you organize concurrency on your machine. It's about how you will communicate with other services. Because the main thing that if someone will try to send you more requests that you could produce, it's not about like how you process this data, have enough data. It's all about how you could scale your application right now. Are you able to do it very fast? And it's about how make applications process more data in world that can be like service scale right now differently.
I think they're different paradigms, right? So in the old days, platform threads were very expensive, but now with the virtual threads and structured concurrency, you can achieve that concurrency in a lot easier fashion compared to reactive program. I think it's a valid point, but I think they have different perspectives on the same problem.
Yeah, but it's mostly it's not about concurrency algorithm or model how you could process it. It's about how you will communicate with services, other services. Because the pressure gives you an opportunity to guarantee that service, some kind of guarantee that service will not send you more data if you don't ask.
Back pressure is part of reactive, but reactive is not part of back pressure. You can put back pressure into anything.
I think the
I think that no, reactive is part of, no, the pressure is part of reactive because it's,
Yeah, back pressure is part of reactive, but you can put back pressure into anything. I can build back pressure into a virtual thread model
yes.
if I'm communicating with it. So it's not, oh, you can't only use back pressure with reactive. You can use back pressure with anything. You just build it into your communications model. The client has to understand it, and that's different from requiring reactive. So the back pressure itself isn't the specific benefit for the reactive model.
You can follow thread per request using the virtual threads and structured concurrency model. It's a lot more simpler. I think that it's just a new thing since Java 21.
Yeah.
Definitely worth a look.
Yeah, I understand what you're talking about. We have organized, try to optimize how this service will work, how we will consume these resources and put it like good way. But from a service perspective, it was very hard. It was more easy to use standard framework or utility that provides it from the box, and you don't need to invest time into it because like you have virtual threads, and you need to write some code on it to add the communication service, and maybe at the end you will receive you implement socket 2.0, something like that. Here it's like okay, we have some standards. How we could organize it. They're very good. I think that mostly it's they will put it live threads using into socket and their concurrency model. Yeah.
Any more questions?
So on the application any JSON versus JSON, let's say I have a JSON that's paged. What would be the benefit of using any JSON?
With streaming JSON, it's very hard if you need to understand how many pages you have. It will be very difficult. It's more about like streaming. For example, if you really need it, you could say, okay, make one request that could give you a count of requests, and then you could stream all this data from all the pages if you need. But in most cases, I think that you don't need it because you need just one single page. Maybe you will not need all data from other pages. If you really need it, yeah, streaming will be good enough for you. Because on receiving huge amount of data, like reading all it, application like yeah, very good.
I read it. But are there any difference on the headers, for example, or things that you don't send when you're using any JSON?
Could you clarify the question?
Yeah, so like if I have a paged request, I will send the full, all the headers of education, everything. Now, with any JSON, the way that I understood is that we're going to stream the output.
Yeah.
So in that stream, you're not going to send headers or like, how does it work?
You could send headers. It's the same HTTP request, but it's like more simply, and you don't need to serialize it into like array. You will send it item by item. It will have all these headers.
Okay, understand. Thanks.
I'm not sure if I understood the advantages of the sending TCP. That it's a smaller packets. Why is it better? It was somewhere at the beginning.
So
More earlier. Yeah, somewhere here, or maybe it was.
It's you don't need to wait more time on waiting all this packet or all this whole HTTP request, like whole list of elements that you need. it's about time to first byte. When you need to receive first byte as soon as possible, without awaiting all this data while it will be serialized or collected on other side.
So are you talking about reassembling the TCP segment, right? That in all it's quite large, so you have to wait for I don't know how many packets to reassemble some big chunk, and with the new one it's like you are getting closer to like smaller segments.
Yes.
Because like if we are getting into a lot of many small packets, that's also not really good, right?
Yes, it's this is why. So when you have two small packets, it will be not efficient because you have two size, you have your packets that should be sent. Yes, and when it's not fit into two size, it will be not efficient. So your packet should be big enough to fit into it, and not so small. So when you have big enough messages, your throughput will be efficient. If it's not so big enough, it will be not efficient, and classical JSON with serializing with big JSON collection of JSON elements data will be efficient because it using both messages of batches.
Because if you are talking about the packet size, like 1500 bytes is a standard optimal, or maybe jumbo frames are a bit bigger, but from that right?
Yeah, but for example, it's also depends on what you're trying to stream. Maybe you're trying to stream local messages. Yeah, they could be small if you're I don't know writing like just HTTP statuses or something like that. They could be very good or big. Maybe you stream messages like that user trying to chat. Maybe payment transactions. So you need to understand with what are you working, and if it's really good enough for it, use application streaming. If not, no.
I mean, the point is that NVJSON is more likely to fit that 1500 byte buffer than a full JSON if you're growing things. So it scales very nicely. It aligns with that.
I think we have to wrap because we have pizza in the other room. Thank you, Ali. If you have more questions, Ali is still here.
Yeah.
So you can ask. Are you plan to go with us to the platform?
Yeah, sure.
Yeah, so
People who are online need to wait for because
so the pizza is in the kitchen.
pizza is only in person.
And we will start the next session with Carly. I think like 5 past, 10 past maybe. How you have 45 minutes, yes?
Well, this is about 30 plus questions. So yeah, 45 works fine.
Okay.
So for this pizza,
Huh?
So apologies to the live stream bunch. If you've got any questions, like feel free to ask me afterwards. But for those of you in the room, I'm going to change this slightly. Rather than take questions at the end to try and make this a bit more engaging, I will ask you questions, but also just put your hand up and we'll try and do our best to kind of weave it through together and see if that works in terms of engagement. Not every speaker is going to want to do that. Some want it at the end, but we'll try it out. Does that sound good? Cool. So as the title suggests, I'm going to talk about cultural anti-patterns this evening, about software engineering. Now, I could probably rattle on and based on my experience, I don't want to say have a moan, but certainly discuss a lot of the things that I've seen in the past in a lot more detail. So I could double the length of this. So we can go through this as we weave questions, but if you have any particular questions you want to ask me afterwards, that's my link tree. Now, why have I given you a link tree? Because I'm collecting social media at the moment like it's Pokemon. Everyone is all over the place. So if you're on Mastodon, I am there. If you're on Blue Sky, I'm on there. I am still hanging about on X, and I sometimes wonder why. I'm still on LinkedIn as well, and I'm pretty sure I've probably missed another one too. So find me where you are. I'm happy to connect. Don't be shy. And if you think of questions that afterwards and you're like, oh, I would really like to ask Carly that, don't be shy. I'm happy to chat. But I am a developer advocate. I also look after and lead the team of advocates within DevRel at Elastic as well. And last week I celebrated my 3-year Elastic anniversary, which is really strange to say. Thank you. Now, you might be wondering, well, why are you talking about software engineering anti-patterns, Carly? Well, because before that, I was actually chatting to Irene about this earlier, I used to work at Morgan Stanley. For 10 years, I was a software engineer that went through that traditional path of, oh, I'm going to get promoted, I'm going to progress to become a manager and all of that. I dabbled in Scrum Mastery. At one point, I thought, oh, I'm going to be an Agile coach, and then I saw the error of my ways. No offense to anyone that's Agile. I mean, I'm assuming it's mainly engineers I'm speaking to this evening. So if you're a Java engineer, put your hands up. Is anyone not a Java engineer? Okay, what do you do?
I don't know.
I don't know. That's concerning. But you're getting paid to do it, so that sounds cool. Okay, any engineering managers then? Okay.
Technical lead.
Yeah. Leadership role, so tech lead, okay. And yourself? CTO. Okay. So we've got a reasonably mixed room then, similar to kind of mirroring my experience, minus CTO. Maybe one day, but not yet. And because I've got that varied experience, just like yourselves in the room, I've seen all of these things from different perspectives. I've made some of these mistakes personally. I've seen other people make these mistakes, and I've had to voice and complain when people make these mistakes too. So that's why I'm the person to really talk about this. But remember, let's have this as more of a discussion. If you agree or disagree with things, if something pops up and you're like, oh, I'm not sure about that, just put your hand up and ask me the question and we'll weave it through the talk. Because one of the things I wished when I first became a manager was that someone told me what not to do, instead of either spending a bit of time telling me what to do, or quite frankly, for a lot of managers, as I've seen from a lot of feedback from general studies on this, we often, when we go to this point, hey, you're a manager, congratulations, go off and manage people, you'll be fine, you got this. And we don't give anyone any training, we don't point them to any resources. And the fact of the matter is that managing people is a skill. Building amazing software is also a skill. And we need to make sure that we know what not to do. I mean, think about the seminal text on Gang of Four software engineering patterns. That book also contains anti-pattern references and tells you what not to do and what kind of patterns they've found before to get you in a sticky wicket. So why don't we have it for cultural patterns too? So if you want to destroy software engineers, these are all the things that I suggest that you can do that I'm going to be able to cover in 30 minutes. There's a ton more that we could discuss today about autonomy and all sorts of other things. So if you want to do this, I'm going to suggest that you throw as many software alerts at them as possible, that you keep them on call constantly and interrupt their personal lives, that you make sure that you're using performance metrics to compare teams. Yeah, that one always gets an intake of breath. Have a horrible jerkish code review culture. Make sure that you bombard them and overload them with tools as well as alerts. Build flaky tests and keep them in your suite as well, because we need the chance to go and get a cup of tea More on that later. And also just pack them to the brim with so much work that they don't know what they're doing, and stop them attending conferences and meetups, which I'm hoping you're not doing because you're at a meetup this evening. I've clearly got the message. So let's start with alerts. So first things first, who has some form of alerts that get sent to them that they have to deal with from their software? Not many. Is it going to a dedicated support team? Is that why? Yes. So I was not ever in support. I think that's one of the few roles that I didn't get when I was wearing my multiple hats. But we were certainly the escalation point, you know, for particular escalation of issues, right? And when I was an engineer, one of the teams I worked on for several years used to manage their alerts through email. Does anyone still get alerts by email for the ones that showed their hands up? How's that working out for you?
It's still better than anything else because they're coming from Australia, so just because of the hours.
So you've got a time zone thing. So actually it might
Very
make
much
sense.
So, yeah.
So that mine weren't coming from Australia. I didn't have that nuance, but I had tons of these things coming through. So I had them, basically we had QA, UAT and production would all send us the same types of alerts. And as you've probably guessed, production quality systems and non-production environments don't tend to have the equivalent reliability. So you're starting to see where I'm going with all of the message. And the prior leads for this ecosystem love noisy applications and wanted to know about everything. So I would get sometimes hundreds of these things a day in my inbox. That obviously the natural reaction is you filter them out, which means you're not paying attention to them because you filtered them out. But one of the clinchers when I kind of thought, well, the second clincher, we'll get to the first clincher in a moment, but the second clincher when I kind of think, this is not okay actually, is when I came back from 6 months maternity leave and I couldn't open Outlook because the cache was too big. And do you know what was causing the cache and what the majority of these emails were? It was these alerts. That's what was filling up my inbox. And I'm not the only one that this happened to. A colleague had the same thing 9 months later. Anyway, so they weren't segregated by environment apart from like QA, UAT and prod on the email and the title. So it's actually quite difficult to figure out what was going on. But also I realized when I started in the team, they all had these kind of heuristics in their head of when to ignore these types of alerts and when actually to pay attention to them. Because I would see them coming in and I'd ask a colleague, should we do something about these? There's quite a few coming through and they're like, nah, it's fine, it's QA, nobody cares. Or, nah, it's fine, it's at 95% CPU threshold, we should only yell when it gets to 98. True story. Now, with the exception of yourself at the back with the Australia situation, I'm hoping most of us have some form of platform that we use for managing our alerts and configuring them, making sure the thresholds are correct, etc. That's the modern practice. I'm hoping we're less reliant on email now. But it doesn't matter to still have these anti-patterns and heuristics in our heads that we never document so that we look at the situation and go, yeah, stuff's yelling, but this is fine, no problem. The world is not on fire quite yet. You know, it's not the situation where I need to start panicking. Now, does anyone have family that works in like healthcare, anything like that? So I have several family members who are doctors and nurses. My sister is a nurse. And when I was reading up on this, one of the things I found is that in healthcare, they tend to go by this binary classification for alerting. Because if you think about it, you don't want to have a noisy ward where constantly we're sending streams of messages and you have to figure out if it's actually time to deal with this patient that's unconscious. You got a question?
I work in healthcare and that's called alert fatigue.
Yes, there is alert fatigue. And you have quite nicely led me on to this. So thank you.
Well, you did. But...
Does everyone else know what alert fatigue is? I'm seeing some shakes and some maybes, right? So would you like to explain what alert fatigue is?
If you start sending clinicians and other stakeholders that take part in the clinical care, and if your threshold is too low,
Yep.
then they get bombarded with everything.
Yep.
And they just stop
Yep.
trying to process that. So one of those is actually the really important one that says this patient is about to go into cardiac arrest.
Yes.
And then bad things happen.
Yes.
That's it.
Exactly. So if you're being bombarded by so many alerts, you're going to miss the legitimate one. And that's what's going to happen with software systems. And that is why they have this binary classifier in place to say you should only be sending alerts for a threshold where it's you need to actually react and do something, not that you have to figure out if you need to react and do something. Is everyone with me? Cool. Awesome. So we need to apply the same things to these modern observability platforms or to your emails as well. And the way that we do that is we look at our thresholds. And if regularly we're seeing false positives, if we're seeing false negatives, if we're seeing people ignore particular alerts because they've figured out that they don't need to listen to these, or they're marking them as untracked or they're muting them, we need to have a conversation about whether that alert is actually useful or not. Also, don't be afraid to configure them slightly differently depending on environment. So I'm not sure why you might want alerts in QA, but you know what, each situation is different. So those are my general tips there. Who has some form of on-call practice where they have to be available? One person. Ish. Yeah, on a rotation, not constant. Well, if it's constant, then we've got an anti-pattern that we're talking about. Cool. So a few of us are. Jack, I know you're on call. You got on call because every time I talk to you, it feels like you're on call. So I've had my stints of on call as well, and I don't have an issue with on call per se. So let me caveat that, because actually, if we think about the ethos of you build it, you run it, that also means we should be responsible for things when it goes down, and we should be happy as engineers to be a point of escalation, because if we built it, we normally know the nitty-gritties and the intricacies. Support engineers will know up to a point, but eventually it's going to get escalated to us, and that's okay as engineers. But the problem I have is that it's interrupted my life in a lot of ways when it probably shouldn't. So has anyone who's had an on-call experience, has anyone had interruptions, overnight? One, two, several, same. Has anyone had to interrupt things like family outings, holidays? Yeah. Has anyone had it while they've been in hospital? I'm not joking. Story time, everybody. So I had a colleague who was out on parental leave, and I left him a work item because I was handing over because I was pregnant and I was expecting my first son. Sorry, expecting my son. I've only got one. Yeah, he's not duplicated, he's one. And what ended up happening was I ended up my first day of maternity leave. I was in the hospital in the delivery room, and I get a phone call. I'm not on call, by the way. This is a caveat. You can't really be on call and on maternity leave. That seems a bit not right. And it was the colleague that just came back from parental leave. They had a question for me. And the nurse is coming in and staring at me because she's come in with a drip and I'm on the call on the phone, sitting in one of those gowns. Yeah. That's not a great story, but it shows I don't have any animosity towards this individual at all. He's a lovely guy. But what I want to say is the problem with on-call is sometimes we find ways around it because we just want to get the solution to our issue. And we don't think, we just think, I need my question answered. And actually, we should be taking another step to think and consider, should I be calling this person when they've clearly got maternity leave in their calendar? We shouldn't be. Now, I'm not trying to toot my own horn here, but there's something I like to call the Brent effect that's sometimes at play here. So I'm not talking about our favourite character from The Office, played by Becky Gervais. I'm talking about the character Brent from the Phoenix Project. Has everyone read this text, the Phoenix Project? No. Okay, so for those who haven't, you know what, if you want to go read it on, you go. I quite enjoy it. I have found, though, that some people don't enjoy it. I was at a conference at the weekend and I got kind of a lot of the it seems to be becoming the Marmite of software engineering text. But for me, it does explain DevOps principles reasonably nicely. But one of the main ones that struck me when I read it is this character, Brent, who's the senior software engineer who gets pulled into everything. Like he is the guy that has worked on the systems for so long that he gets pulled into every situation, every outage. He has to help form deployment plans, everything. And he becomes a central bottleneck. He's not on call all the time, and they therefore need to find a way to protect his time and make sure that he's directed onto the right things, because as you probably guessed, his work's getting totally derailed as well. And the problem with on-call is that if we don't respect that, and we don't also look at things like balance for how often people are on call, then you end up with situations like that, or like me in the delivery room. So it's really difficult to say, is there a precise number or percentage? Because that's what people normally ask me, like, well, Carly, you're saying everyone should have balanced on call. What's the magic number? We need a magic number. The only number I can find comes from this Google. No, you don't agree with 25%? Okay, you can come back to me. It's all good. So this is the Google SRE handbook recommended value of 25% in your time. So this is based on SRE activity. And the way that this is intended to break down is 25% is on call. You do look very scared. Are you okay? 25% might seem excessive, yeah? Yeah, fair. 25% on call, 50% engineering activities, and remaining 25% on other stuff. Do you have a question, Marcel?
Question and kind of like the discussion.
Yeah.
I think first of all, 25%, I think is the number, whatever number, yes, it depends on the context, yes.
Yeah.
If you have 4 engineers in your team, then 25% is yes. If you have 100 engineers in your team, yes, or organization,
it might be less.
then it might be less. It is completely depends on the context. Yes.
It
For me
does.
at least, yes.
Yeah.
And second thing is more like, what is your opinion about, for example, like in my company, is voluntary to be on call. You have quite decent paid for being on call, and there is a team of people who basically they volunteering for that. Yes, so we don't have much problem with having like someone say, I don't want to be on call, because you can agree and you paid for that.
It's interesting because I've never had the option. I've always just been told to do it. I've never had to think about
The organizations I
optional
worked, and when there was on call, it was always paid.
I wasn't paid.
Like now it's voluntary. In
Yeah.
previous place was we have paid extra. Like everybody have.
Yeah.
It's called it, everybody have paid, so it's not like extra. But
I never got paid extra either. I was just told I had to do it.
I think usually it's a volume.
Yeah.
It's you got lucky. You work in many places that
that you get the
you
optionality.
get the option and rotation. People like
definitely
choose
rare.
to-
but I know usually it's like
Uncle is a bad in the bad context.
Mhm.
I think it will depend on the size of the organization, like you said. When years ago, I was working years ago for a startup in Hammersmith. And
Yeah.
there were so few. Yeah. It was quite interesting actually. We did a job for British Gas once.
Yeah.
They came to thank us for what we did, and they were asking why the rest of the team. I said, that's us. They were shocked. They couldn't believe it.
Mhm.
Not until when I then joined BT, I saw the massive stack of personnel, especially personnel that had.
Yeah.
Implementing ITSM, ITIL modules of support.
Mhm.
That was when I knew the difference.
Mhm.
Because working for a startup, you everything.
Yeah, you do. That's fair.
You get to be everything, yeah.
That is it. I mean, it also depends on the scope. So what I'm assuming here as well is that if you're on call for your ecosystem, you're not being dragged in to support every single application. So for example, I used to work at a large investment bank. When I was on call, I didn't support every application in the bank because I quite frankly didn't know, I didn't know anything about them. And I would have been very useless, particularly working in back office on front office applications that were written in C++, since I hadn't touched C++ since 2011. That was just going to go wrong. I'm sorry. There is obviously certain guardrails that you might need to consider, such as the size of the company, such as the scope of the applications that are under the support as well. But this is just a general guide as well. I mean, what's actually also additionally important is that 25% or some form of ratio like that helps you keep and maintain the skills that are associated with triaging and being on call. Because in my situation, I learned all those by being thrown in at the deep end and being on call. And that can be a bit terrifying and scary the first few times you do it. There are emerging practices now, such as like war games and simulations and stuff that you can do, which are a good way to train up engineers, particularly junior engineers. And I would prefer that we do it that way now. But there's still certain things that sadly you only learn when you're in there and on that call, or when you do get woken up at 3 o'clock in the morning for the second week in a row, which we've all had. Now, the next thing we'll talk about is metric weaponization. So I think you remember telling me from my intro, I briefly also was a Scrum Master and dabbled in Agile coaching. And one of the things that I used to discuss with the coaches quite heavily was this notion of management using metrics to compare teams. Has anyone seen anything like this before? Yeah, we're all nodding because we've probably been in the middle of it. You're like, maybe a little bit. Cool. So the types of measures I've thinking of and have seen actively used for comparison, firstly is velocity. So we all know what velocity is. We're all nodding. Yeah, so we're not going to get into this debate of story points because we'd be here all evening just talking about story points and t-shirt sizing and all those other things. But what I've seen with velocity specifically is, look, if we're saying to teams they have autonomy to estimate stories as they see fit, and they own their scale for story points, how can you compare their velocities and the completed points in a sprint? Because the scales are different, they don't match up. So it doesn't make sense. Also, if you include the best practice of swarming in that particular situation as well, where multiple people should be working to try and just solve an issue, the fact of the matter is, how do you attribute the amount of story points to, person 1, person 2, and person 3? Like, it gets ridiculous. But I've also seen people compare DORA too. Has everyone heard of DORA? No. So I've got some nods and shakes. So for the shaking heads, these are the set of metrics around how reliable and how easy your system is to change and recover from failure. It's popularized by the Accelerate book. So it's the original set of measures from that, with the addition of reliability within the last couple of years, if I remember correctly. And I've seen teams have these compared as well. Now, I've also been in teams where we have different ecosystems, and trying to compare our reliabilities doesn't necessarily make sense. So I've worked in teams that still have mainframe presence in the 2010s. We have, other aspects of aging applications, poor testing in certain older components, things like that. But if you're trying to compare us to another team that has, a small modern set of really small microservices, truly small microservices, not the huge behemoths that we like to call microservices. If you have a team that's managing those with high test coverage, modern practices, you're kind of comparing apples with pears again, because these teams have their own different challenges, but you're trying to equate them that they're similar, and they're not. Now, some people have told me about space metrics and being compared for those. Now, space, has anyone heard of these ones? These ones tend to be less common. Yeah, so space metrics, I believe originally came out of Microsoft, but I might be wrong on that. So someone can go check and let me know later. But these are around satisfaction, performance, efficiency, flow, communication. And they normally tend to be captured by surveys primarily. Now, the reason I mention this one as well, not because I've ever seen them compared, is because this piece came out 2 years ago that caused one of the biggest stinks I've seen for a while on Twitter, before Twitter turned into X.
That one.
Have you seen this one? Yeah, you're
metric tons of horse manure hitting a massive bag kind of discussion.
Yeah, that's exactly what happened.
Yeah.
So this piece, for those who are not familiar, came out from McKinsey in 2023.
Surprise.
Sorry?
That's a surprise.
Yeah, that was pretty much what people said actually at the time as well. So what happens, if you want to go read it, you can. It's still up as far as I could see, at least when I checked a few months ago to take a screenshot, it was. What they're trying to do in this methodology is, it's obviously a call to managers saying you can measure the productivity of your software developers by using a combination of DORA and space. That's basically what it's getting at. Now, I didn't write my own rebuttal. I just kind of rolled my eyes and said, I'm going to go over here now. But there was some great rebuttals written that I encourage you to go and have a read at. Now, the one from Dan North is particularly good because it's structured as like a review, as if it was like a research paper. And he points out some really interesting things, like the fact that their methodology doesn't take into account particular types of important activity, like infrastructure tasks and testing, which I think are quite productive. I wouldn't see why you would want to discount those. But then there's also the piece by Gergely and Kent, which is also a very good read and talks about numerous factors. But the one I want to call out is Kent's comment about how we use metrics in software engineering, where we get into this really bad habit of thinking, we measure this. And now it ends up in all these unintended places that we don't expect, like comparing teams on their effectiveness, like performance reviews for individual engineers. And that's based on his own experience. Now, I'm hoping no one is doing this, but one of these emerging things called SLOs have appeared over the last few years, which indicate reliability of a software system. So by that same proposition, we'll be measuring these very soon, and I hope we really are not. As I said, you can't compare two sets of teams given the complexities of their factors. You can only look at, are they building the right things? Are they providing value, which you can use by things like key performance metrics and things? And ultimately, are they getting better? Are their own measures for change and reliability going in the right direction? That's how we prove we're on the right track, not by comparing them and weaponizing it.
I love the idea of a personal SLO for your own productivity and a burn down chart.
You're going to take that back to the team, Jack, tomorrow? I might have planted a bad seed here. Right. The next thing we're going to talk about is code reviews. So we're not going to get into this debate, just to clarify, of code reviews versus mobbing versus pairing. I'm talking about doing some form of feedback on code of some description. So does everyone who doesn't have, that's an easier question to ask, who doesn't have some form of review process on their code? No, that's reassuring. So it's really funny because when I was thinking about this one today, because it keeps flashing up again. So it was actually a few years ago that this one happened. I was a lead, so similar kind of situation to yourself. And we had this really senior engineer who was wanting to progress. And one of the things I'd said is, well, one of the ways to progress is you mentor other engineers and looking at forming a plan and all these things that you normally do to try and grow an amazing engineer. And then we got a new developer in the company that joined our team, like new periods, but shiny new. But they hadn't worked on the version of Java that we've been using. So this is basically going from pre-streams to streams. So that kind of paradigm shift that we can appreciate takes us a bit of time to learn, correct? So this is not a direct quote because, there was stuff going on in 2020, but I think we can all agree that it's not okay to write stuff out like this around competence. I think we can all agree on that. There's so many problems with writing comments like this. It's not actually constructive. It doesn't tell them how to improve or get better. There's no resources on how they can learn these new patterns. And it's also not a welcoming environment. And I actually speak to people that have came back from career breaks, parental leave, maternity leave, or they've transitioned out into manager and other roles and have come back again. And they are terrified of doing their first pull request coming back because of the potential for just getting totally torn to shreds, because code review culture is sadly not very nice at times. Now, we need review culture. I'm not saying we don't. But if you actually read the updated forward by Kim Scott in her Radical Candor book, she has to clarify that there's a difference between radical candor and being at, quite frankly. Now, I thought this was just me, I thought maybe it was isolated this team and this culture. Maybe it was to do with the industry. I don't know. And then my colleague, Maha from Elastic, absolutely amazing engineering manager, gave this talk at DevOps UK last year with very similar patterns. And that kind of got me thinking, this is not just specific to that team I was in. People are seeing this everywhere, and it's not pleasant. And we need to actually make it pleasant again. Now, there's things that we can do to make code reviews easier. Some you might agree with, some you might disagree with. But again, let's have the discussion. Let's, raise your hand if you've got a point. So I'm not saying write an overly detailed essay. I'm saying we need to write quantifiable things to say what's wrong with it, or what's the issue with the pattern, or point people to resources, or ask questions to clarify understanding, not to question someone's competency. Also, let's think about using checklists and have agreed things to look for in code reviews. We have this really weird situation with junior engineers that they learn a code review most normally by doing their first code review, and no one really tells them what to look for. That was my situation. But also furthermore, when we're encouraging things like full stack practices, so like in the situation where we had a shortage of front-end engineers, there was me and a handful of others. So we had our Java engineers writing Angular features in the front end. Nobody really taught them about the practices, and the patterns of what's good and bad practice differ between JavaScript and Java. That seems quite obvious, but we don't actually have proper checklists and guidance to help them. So we should consider adding those things to our cycles. And then we also need to think about that line of opinion. We all have opinions. There's nothing wrong with having an opinion about good code style. But if you've got a check style that's been in existence for several years and a new engineer comes in and wants to change the entire thing, including where braces are positioned, that's probably not a very healthy thing to consider. And I have had that happen as well. We need to make sure that it's an inclusive culture, that we are happy with code reviews, and that we're comfortable giving true radical candor, which is, I'm not sure this pattern makes sense in this context, so can we try doing this instead? Or why did you do this pattern? I'm keen to understand. Because if we don't, quite frankly, people just won't do things. There's this ethos in agility that talks about this idea of you need to do the things that hurt more often. And it's meant to be around deployments, because deployments used to be these huge, big bang things. And then you'd spend half the weekend trying to roll it back again because it went disastrously wrong. But if we do this with code reviews as well, people won't want to do them. They'll put it off. They might find ways around it. So I had a team of engineers once, it was my boss was looking after a team of engineers, and he asked me to start looking at the reviews because they were cross-reviewing stuff and they were based in a different time zone. But because they were all junior engineers, the quality of the code in the project dropped through the floor, including the coverage and things like that. So they were trying to kind of roll back by having a senior engineer help and guide and help bring it up. But if we had an inclusive culture to start with, maybe they wouldn't have felt like they needed to do that. So think about the potential ramifications of what happens when you don't have this culture as well. Right, tools, technologies, we use tons of them. And there's probably more on here that are not there. So tooling's an interesting one because it's great to have choice. And there's nothing wrong with having choice, but we need to think about the factors that inform our choices and inform when we switch them. So I work as an advocate. I get the honor of talking to so many amazing people at conferences, learn what they're doing, what they're using. And quite often I talk to people who say, oh, we used to use Elastic, we've moved to something else. Or we used to use this and now we've moved to Y. And, I'm a chatty person. I normally ask why. And the top reason that an engineer gives me, what do you think it is? It's money, it's cost. It's my manager said, we're changing to this because it's cheaper. Now that's fine, as long as there's parity for things like productivity. There's nothing wrong with that. But if there's not, and it leads to making your job harder, then clearly it's not been evaluated as a constraint. So I did speak to one individual who'd said for a while, yeah, we've got so many different tools, we're trying to consolidate. I'm like, oh, that's cool. So what are you thinking of doing? And they went, oh, we're going to use Amazon CloudWatch. I went, oh, that's great. So you're an AWS house. Oh, no, we've got stuff everywhere. I can see a major fault with this. How are you? So I went, so how are you going to observe and track all the other applications? We don't know. I'm terrified. Because that's the thing. Clearly a manager's made a choice that's nothing to do with productivity at all. Absolutely nothing. That's not been factored in. Now, productivity, when it comes to changing or selecting a tool, it's not just the value it gives you. It's also when we're switching, thinking about the amount of effort it takes to move things. So if you're moving from one observability platform to another, are you going to have to port all that data over? Is that something that's possible to do? Are the formats the same? Are you using an open standard like OpenTelemetry, which might make it easier? Or are you stuck using open tracing, or are you locked down to a particular provider, meaning that there's going to be more effort? All these things are a productivity sucker to the team who are going to have to spend an inordinate amount of time solving this problem. So maybe instead, we should have a think about the productivity angle. We should also make sure we train people in new tools, which seems obvious, but quite often we just throw tools at people and expect them to figure it out. And we also need to realize that people might be slower for a little bit because they've lost all their shortcuts, they've lost all their queries, and all that muscle memory is gone too when you change tools. So we need to factor those choices in. It's not just about cost. Non-deterministic tests. So who is willing to admit to me this evening that they have a test in their suite somewhere that passes randomly and then fails when they rerun it? Oh, guys, I'm so disappointed. I've been there too. Actually, I have a name for them. I call them the tea tests. Do you know why I call them the tea tests? Because it's the point when I rerun it and then go at the coffee point to get a cup of tea. That's my point to go and get away from my desk. Anyway, the thing is, we often talk about coverage and we get so heated in these debates of what coverage percentages should be. Should it be 20%? Well, I think we can agree it should be 20% if you're really worried if your coverage is 20%. We all agree that our tests should be legitimately covering and asserting valid things, not just initializing stuff and going, hey, my coverage is great, it's 95%, but I test nothing. We focus too much on these little problems and then we have these t-tests. It just makes absolutely no sense to me. That's not a great indication on quality. I'm slightly worried, Jack, that you put your hand up. I'm saying nothing. It doesn't give a good indication of quality. It's one of these things where we're just okay to briefly cover over that crack. Now, there's a great video by Trisha G on Dave Farley's CI YouTube that talks about this very topic. And I'm inclined to agree with what Trisha says on this one. She is awesome. But one of the things she says is you should identify these tests. So you can use things like your own scripts. There's loads of auto retry tools. All these things are available to help us find them. But it sounds like, to be perfectly honest, you've already found them. So you've already figured part of that problem out. And then the next thing we need to do is we need to either fix it or we delete it because you can't trust it. Testing doesn't prove the absence of bugs. I remember reading this in a research paper years ago while still at university. It doesn't prove the absence of bugs, just the ones that you have determined might be there and you've tested for those cases, right? We've all covered things like equivalence partitioning, all that stuff, right? Fix it or delete it. Whenever I say delete, the testers get scared and run out of the room. I understand why, but you can't trust this test, so why is it still there? It doesn't add anything. So the next thing is around work items. So I guess a quick show of hands. Who structured their work using Scrum? Most of the room. Any safe people? Scaling Agile framework? Sorry?
No.
I'm very happy about that, actually. I'm not a fan of safe. Big room planning just doesn't make sense to me. Anyway. Any Kanbaners in the house? No.
I think most of the teams use kind of.
If you support use Kanban.
Yeah. I have used it.
Kanban is what happens when Agile hits reality.
I love that quote. That should be on a t-shirt. That's inspirational, man.
I mean, it's just like you may say that you're not doing it, but that's the confession. So, you start with an Agile and it's all going great, and then management weighs in and emails arrive and alarms go, and then you're doing Kanban.
Yeah. I've actually had a similar story to that. So we started with Scrum and everyone started hating Scrum and seeing so many issues with it.
I think it's just because I'm from industry, not from my IT. And I think in IT, people don't understand what Scrum is.
Yeah.
And what this Agile is. Completely don't understand because this is not management. Agile and Scrum is for smart people, for very high skilled people, not for all teams. These people is just good for a start to set up a rules and then you leave it. And leave these people alone, they're working fine after 6 months.
It's meant to encourage autonomy, yeah.
Yes, but every management, what happens in IT, for me is crazy, yes, because I'm from another sector of industry. And just people in IT don't understand 99% of teams.
Yeah, it's a fair point.
I think most businesses want Wagile, right? They want to be fashionable in doing Agile, but they want the assurance of it's going to be delivered on this date. So this is the date, now work back. It's like, okay, so you want Wagile, okay.
But Wagile and Fragile are not that far away, are they? So yeah, I mean, I've worked in a mixture of Scrum and Kanban for software projects in both cases. I've seen it can work quite well. I've seen it can be a disaster. It's around the ethos of improvement and how you apply practices that tends to be the problem. And then also you kind of talk this notion of management getting involved, the weaponization of metrics, all those other things start to bleed in. But if we look generally at just work items and how we structure our work, does anyone recognize that their board looks similar to this? Yeah, so maybe we've got items that someone's working more than one item at once. We're probably ignoring work in progress limits at certain points, which is why the code review section is red. And we potentially have these kind of gated, like the code review one, these kind of gated transitions that can fail and we end up going back a step, which can mean that we can end up going from 2 tickets to 3 tickets working in parallel. So I know we talk about there's stereotypes out there that I'm not going to mention around, multitasking and parallel working. But parallel working and multitasking is a myth. When we think about a deep task, what we're trying to do as software engineers is encourage something called flow state. So has anyone come from a psychology background at all? So I was privileged at the weekend where I did a similar version of this talk with a scrum master and psychologist in the room. And what she was explaining was this notion of flow state is actually a real thing. And it's around different processes and how they interact. So we all had that moment, we're just in the zone, writing the code, happy hormones are buzzing away and we just know we've got this. That's what we're trying to aim for when it comes to flow, because we're focused on one task and we're performing it and we get a sense of mastery and achievement when we're doing that. That's what we want as engineers, right? Because that is us being productive. And think about the times when you've been juggling multiple things at once. Do you find it as easy to get into that flow state? No, you don't. It's harder. And it's harder because you've broken one of the principles of developer experience, which is to minimize distractions, and you've maximized yours. Especially if you did all the other things I talked about with regards to alerts and on-call, because you'd just be buzzing and constantly jumping between other stuff. And that's before we factor in alerts from your personal life, like the social media stuff or the messages from your mum that hit at random times on a Tuesday. What we need to do is actually think about including space in addition to allowing people to multitask. Because the other factor as well we need to think about is if you pack a sprint so tight with no flex in it, what if someone has an emergency? Are you still expecting people to do all of that work? Some managers are, and they really shouldn't be. So one of the things I like about Elastic, we don't do this in the advocacy team, but Jack, I'm sure you can vouch for space-time weeks in the engineering team. And these are portions of time where engineers get to work on something a bit different. They can propose ideas of things that they think will make them more productive, new ideas to bring into the project, and they propose them. And it's a full week. Is it every quarter you do it? Every quarter. Now, I've done similar things. I've done mini Friday hackathons that have ended up in new features coming to production that have been proposed by engineers. I did that in my teams before. And also I overheard someone on Saturday talking about they're going to try and do Learning Fridays in their team. All these kind of things give people space to try stuff that mean that you're able to innovate and also give people, enjoyment and ability to capture flow state, as well as also making sure that they're not overly structuring and completely cramming a sprint full of tickets. Now, the last one I'm going to talk about is a bit meta, because I'm giving it at a meetup and I'm fully aware of the fact. Does anyone ever have issues trying to get sign-off or agreement to use conferences in their work? That makes me happy, actually, that I'm not the only one that's had this happen. That's cool. Has anyone ever had situations where they've skipped or missed a meetup because they're so packed with work that they've ended up staying late? Yeah, we've all been there too. We know how awesome meetups are because we're here. I don't have to put that forward that you're getting a chance to learn, you're getting a chance to connect with people. In my experience, it can be made harder to get people to go. Money can be a factor, particularly if you look at conference tickets, and I've certainly had issues with trying to justify attending a conference and getting sign off for that, especially if you have a situation where your training budget is coupled to particular providers and internal systems and things like that. Developers often don't have a choice. And one of the things, so my husband works for a different company. He works for Capgemini, actually. He has a budget that he can use himself every year. So he can decide. I mean, there's obviously some rules and stipulations, but he can choose. He can say, I'm going to use my budget this year on a conference ticket to DevOps UK. or I'm going to use it for this course or this certification. And I think that's a quite powerful thing. Sometimes I heard someone over saying, I don't need to go to you don't need to go to the conference, just watch the YouTube videos later. Now, I know this seems a bit meta because there's literally a stream going on right now, and this will go on YouTube again later. But I'm sure you can agree that you actually got more out of this because you were here. And that's the thing. It's this community connection, this hallway track aspect. That's the bit that we miss when we just watch back the YouTube video. But the final one is bureaucracy and red tape. So I guess, has anyone spoke at a conference before? It's a few of us. How many of you had to get your content approved before you went? I have. I've had to have my content approved. I've had to have approval to attend even if I wasn't presenting. That was how things used to work in one of the companies I used to work for. There's nothing wrong. There's particular industries with reputational risk and aspects where that might be required, and that's absolutely okay. But there's benefits to use an organization sending someone as a speaker to a conference. One, they get a free ticket, so you're not having to deal with the sign-off budget issue. Secondly, they're actually showcasing what you're doing at your company. They're an ambassador representing your company, which helps for things like hiring. There's a reason why a lot of companies host meetups when they're hiring. It's because they get engineers in the door that they can talk to, that they can show, hey, we're happy with you doing this stuff. All of these things center around learning and community and growing. So we need to make sure that these options are available to people too. So we've talked about a lot. You guys have contributed some fantastic ideas as well. So I appreciate you all for that. But these are all the things that we are still doing that are destroying software engineers. So we're bombarding people with alerts. We've got them on call too often, or calling them at really inopportune times. We have compatible metrics that we shouldn't, because it weaponizes and demoralizes people. We have horrible code review cultures. We're overloading people with tools. We've still got non-deterministic tests because a few of you put your hands up and admitted this evening. So there you go, an action to go and fix those. We've got work schedules that are ridiculously packed, and attending conferences and meetups is hard. And there's a few more that I could have landed in, but I just didn't have the time. And I'm sure there's a few more that you can think of that I've missed too. But irrespective, these anti-patterns have outcomes that we need to think about. As a hiring manager, I know it takes a long time to find that right person. So I don't want someone to leave for stuff like this. But if you keep doing these things, you're going to end up with burnt out, sick software engineers who potentially are going to get signed off. You're going to have potentially frazzled junior engineers who are trying late at night to get things fixed, because the senior engineer is also working late to try and get stuff fixed. And people are just going to leave. That's how this works ultimately. That's the final destination here, you know? If you think back to the Monty Hall problem, this is the door that is definitely statistically more likely to happen. So we need to do other things instead. And the other things we need to do, which we've woven through, and some of you have suggested your own as well, is we need to stop the alert flood, alert for legitimate symptoms. We need to have balanced on call. You might not necessarily agree with this 25%, but that balance on call limit is needed. Making sure people are all contributing and doing their bit. Make sure that performance metrics are used to track team improvement. Don't compare them. Have constructive code review. Don't be a jerk, okay? Use the right tools. Don't just switch because one's cheaper. Make sure that you can actually observe your whole application ecosystem, as we talked about. Make sure to fix the flaky tests, so some of you have an action item tomorrow for when you log into work. Make space in engineering time. Don't pack people to the brim with tickets. And also make sure that they get to learn and come to events like this, and also DevOps UK, where I might catch some of you next week. And with that, guys, it's been an absolute pleasure. Thank you so much. And then around. Cool. So, I know what time it is.
It's quite late.
It's quite late. Will we say no to questions then, since we've had a few of these through anyway?
You are the boss, so.
Has anyone got a burning question you really want to ask? Just like a no. Well, look, you all have me on LinkedIn or Mastodon or Blue Sky or whatever you picked on Linktree. If you think of anything, feel free. And Marcin, do you want to say anything for closing?
Let's make a photo together.
Yeah, tradition says Maybe there is like nice background, or where should we do it? Here or?
Do you want to do it in front of the elastic sign if you can fit everyone?
Yeah, that would be even.
Yeah. Right, guys, photo time. If you want to all gather in front of the elastic sign, we'll take a quick photo.